This is chapter 2.2, linear functions and function notation notes. The linear equation y equals mx plus b, where m is slope and b is the y-intercept, can also be written in function notation as f of x equals mx plus b. And again, that's not f times x, it's read f of x so that you don't say it incorrectly. Another thing you need to be aware of is that a function doesn't have to be named by the letter f. Other examples can include g of x and h of x. Now, first you have to know, is it a linear function? Again, we're not talking about is it a function, is it a linear? Does it form a line? And if it is, or is not, why? So let's look at this first one. If it's going to be a linear function, it's going to be in the form y equals mx plus b. So that's what you're going to need to be looking for. So f of x equals x squared plus 2x plus 1. No, not a linear function because you've got this exponent here. It's to the second power, which makes it a quadratic function. The second one, f of x equals 4x minus 1. Yes, it's a linear function because it's y equals mx plus b, and y can be f of x. So just so you understand, y and f of x can be used interchangeably. This next one, g of x equals x over x plus 1. That is not a linear function because you've got a variable in the denominator. To be a linear function, it has to be in the form y equals mx plus b. Going on, this one, g of x equals 5 minus x cubed. Now, it wouldn't typically be written this way. Correctly written as g of x equals negative x squared or negative 1x, negative x cubed or negative 1x cubed plus 5. And this is also got an exponent. It's to the third power, so no, it is not a linear function. It's actually a cubic function. This one is a bit challenging for students, this next one, h of x equals negative 4. And that is, yes, it is a linear function. And the reason is if you take y equals mx plus b, you can put the negative 4 in for the b part. This, in fact, has zero slope. You could have 0 times x, which would be nothing, leaving you with negative 4. So h of x would be h of x equals 0x minus 4, which would simplify to h of x equals negative 4. So this one is fine. Yes, it is a linear function. This next one, h of x equals 9 over x. A little different look at this one up here, g of x equals x over x plus 1. This is not a linear function because, again, you have a variable in the denominator. And the final one, r of x equals x over 9. Now, these two look a lot alike, but this one doesn't work. It's not a linear function. Denominator has a variable, but this one's okay. It can be written in the form y equals mx plus b. So it's r of x equals, and instead of writing it x over 9, we can write it 1/9 x. So r of x equals 1/9 x plus 0, which equals r of x equals 1/9 x, or x over 9. So this one is just fine. Now, this next part, we're going to evaluate the function when x is 3. We're going to use PEMDAS to do that. What I'd like you to do is I'd like for you to try, I'm going to do a couple of these with you, and then I'm going to have you try the last one on your own. So I'll do a couple, and if you think you're good after one, then shut the recording off, do it, and then check your answer. All right, so we're going to have evaluate the function when x equals 3. So f of x is going to be f of 3. We substitute in 3 for x, so 4 times 3 minus 1. f of 3 equals 12 minus 1. f of 3 equals 11. Now, if you feel confident, you can do the next two on your own and then turn it back on and check. If you don't, I'll do the next one with you, and then I would like you to try the third one on your own. So g of x is going to be g of 3 equals negative 2. You're substituting in 3 for x. You're squaring it plus 5. Using order of operations, you have to do exponents first. That's the e part here. So g of 3 equals negative 2 times 3 squared, which is 3 times 3 times 9 plus 5. Now, multiplication and division come before addition and subtraction. So g of 3 equals negative 18 plus 5 and negative 18. G of 3 equals negative 13. Okay. Again, I want you to try that last one on your own. So turn it back on when you've finished. Okay, P of 3 in this last one equals 26. If you had any problems with the computation, you should take a moment to go through the steps right here. We're now going to move on to that word problem, and we're going to be looking at a variety of things there, so go ahead and get ready to do that. Okay, the first thing I need to do is fix the typo in your notes. This should say cost of 100 minutes, not cost of 100 calls, so go ahead and fix that. And then it says a cell phone company charges $15 per month plus 7 cents per minute for all calls. 15 is a constant. For every minute you pay 7 cents, so that's going to be a variable amount. We're going to go ahead and write what our variables are. We are going to have T equaling minutes and C is going to equal total cost. You always should write down and define your variables so people know what you're talking about. All right, so our function is going to be f of t. You could have any letter you want. I chose f. And we know that 15 is a standard set amount. So no matter what, you pay $15. So that's going to be y-intercept. Let's put a point right there on our graph. So if you haven't drawn the graph, take a minute, pause the recording, and draw the graph. Now, for every minute, t is going to be minutes. We're going to pay 7 cents a minute. So 0.07 t, a little curly tail on that t so it doesn't look like plus plus. And another way you can write f of t is y. So they mean basically the same thing, but in this case we're dealing with a function, whereas y is just an equation of that line. All right, now we're going to go ahead and calculate the cost. So we want to know the cost at 100 minutes. So C of 100. So actually, let's change this. Shouldn't have been F. I'm actually really not changing F. I'm choosing C because I find this as total cost. So this should be C of T. I could have chosen F, but I'm going to change it to C of 100. And that equals 7 hundredths, or 7 cents, times 100 minutes plus 15. You don't really need a calculator because when you multiply by 100, it moves the decimal place 2 places to the left, so you end up with $7 plus $15. So C of 100 equals 15 and 7 is 22. So C of 100 is 22. And I'm just going to write this in a sentence. It costs $22 to talk for 100 minutes. All right, now let's graph that. So your graph, we knew that we had 15 was the set amount. That's the lowest you can go. And so I chose to go by 5s, 5, 10, 15, 20, 25. 100 minutes is a lot of minutes, and so I had to go by something larger. I chose to go by 20s. You could have probably chosen 25s as well. So we go out to 100. We go up to $22, which is about right here. And then we connect this with a line. You can't have anything on the other side of 15 because you're not going to have negative amounts. But you could continue calling beyond 100 minutes. There are limitations to that, but for just the sake of doing this, we will put an arrow on that ray. Okay, let's talk a little bit about the domain and ranges that you might see. And again, notice that I've labeled this axis, my x-axis with minutes. Your x-axis is frequently going to be some kind of time. In this case, we did t for minutes, and I got to fix this right here because I didn't fix it from the last one. This is an f of t. It's going to be c of t. So c of t or y is your total cost. Notice I've labeled my axes. I've put numbers on my axes. Very important when you're graphing. Okay, let's talk about domain. This is important. Your domain are your input values. None of these can be negative. You're talking a certain number of minutes. You could talk 0 minutes, so 0 could be. You could talk no minutes and have a cost of $15. But you can talk beyond that. So your domain values, your input values, or your minutes have to be greater than or equal to 0. The domain values, let's try that again. I wrote this wrong. Anyways, the domain values t have to be greater than or equal to 0. Now let's go to the range values. The range values are either going to be the y, but in this case we're going to use C of t. Okay, the C of t can't be a negative amount, and nor can it be 0, because you are going to pay $15 whether you talk on the phone or not. So it can be equal to 15. If you talk 0 minutes, it's going to cost you $15, but it's going to be at $15 or more. So C of t or y is going to be greater than or equal to 15, one or the other. You can write it either way. Okay, now we're going to move on to the graphing on the back of your notes. So if you please pause this, get caught up on this one, and then flip it over. I'm going to do the first one with you, this h of x equals 4x minus 1, give you a little hint on the second one, and then I'm going to ask you to graph the last two on your own. It says graph the function, pick 3 simple input values, and create an input-output table. Now I am going to pick -2, 0, and 1 for my domain values. Do you have to pick those? No. You might want to pick at least one that works. And then you'll look at the line to see if your points would fall on that line. If you're a little uncertain, go ahead and pick -2, 0, and 1, and then you'll know for sure if you've got it right. So we're going to do the first one together. So it's h of, this is how you set up your tables, x, y work. So you're going to have h of -2 equals 4 times -2 minus 1. And you have 4 times -2, so h of -2 equals -8 minus 1. And I'm going to actually change that mentally right now to plus -1, which gives us -9. So it's -2, -9. I'm going to plot that right here, -2, -9. That's your ordered pair. Then I'm going to go to 0. 0 is always a nice easy one, good one to choose. H of 0 equals 4 times 0 minus 1. I can do that mentally. 4 times 0 is 0, minus 1 is -1. So my ordered pair is 0, -1. I'm going to plot that. And then I'm going to go to 1. And I've got h of 1. Let's extend these lines down a little. Equals 4 times 1 minus 1. H of 1 equals 4 minus 1, which is 3. So my ordered pair is 1, 3. Well, you probably already caught this. I caught it as soon as I saw they weren't in a straight line. This was -2, -9, and I plotted it in the wrong place. So let's go back and fix that. So sorry about that. Let me make that negative a little darker. And yeah, I wrote it there, -2, -9. And I know this next one is going to be 1, 3, so here we go. Again, you're going to use a ruler. Very, very important that you use a ruler to connect your points. Mine aren't nearly as pretty as yours will be. It's a positively sloping line. Okay, you're going to try the second one and the one below it. But before you do that, let's take a look at this second one. It's P of t equals -2 minus 2, which can also be written as P of t equals -1 times t minus 2. If you're not getting your points in a straight line, because this is a linear function, you're going to want to look at if you properly multiplied whatever it was by -1. So go ahead and try those, and then turn on the recording to see how you did. Okay, for the second one, you have -2, 0, which is plotted on the x-axis. This is an x-intercept. You have 0, -2, which is plotted on the y-axis, because there's a y-coordinate, so that's a y-intercept. And 1, -3. And when you connect the points, you can see that they form a straight line. Okay, again, you can see that this line is a linear function because it's forming a line. And your ordered pairs are -2, 9, 0, 5, and 2, 1. If you use the domain values of -2, 0, and 2, you get the range values of 9, 5, and 1. Your assignment is page 76 to 77, 14 through 23, 28 through 33, and 38 through 42.